SOH CAH TOA helps us work out unknown angles and lengths in right-angled triangles, and it feels right that we can use triangles to help us understand how to use them. SOH stands for sine theta equals opposite over hypotenuse, and there are similar equations for cos and tan. But let's take a look at this triangle. It has a right angle, one angle of 30 degrees, a side length of 10, and an unknown side length of x. When we're presented with this kind of problem, the first thing we need to do is label the sides. The side opposite the given angle is called the opposite. The side between the given angle and the right angle is the adjacent. And the side opposite the right angle is called the hypotenuse. So let's pull up our equation again to see if we can start filling it in. We have the term sine theta, where theta is our given angle, so we can rewrite this as sine 30. The next term in our equation is opposite, and this was the side we labelled a moment ago. We know that its length is equal to 10 meters. And finally, our hypotenuse length is unknown, so we'll call it x. So now we have the equation sine 30 equals 10 over x, and when we multiply both sides by x and divide both sides by sine 30, we find that our hypotenuse length is 20 meters long, and we can add it to our diagram. So now we know our hypotenuse length. Let's say that we wanted to work out the length of the adjacent. When we take another look at our equation, we see that there is no term for the adjacent, so we're going to need to use a different equation. Let's take another look at our equations again to see if we can find one that can help us. We can see that both CAH and TOA have terms for the adjacent. We could use either of these equations, but let's start with CAH, where cos theta equals adjacent over hypotenuse. We know from before that theta is 30 degrees. The adjacent is the side length that we're trying to figure out, and our hypotenuse length is 20. So putting those numbers into our equation, it reads cos 30 equals the adjacent divided by 20. Multiplying both sides by 20, we find our adjacent is 17.32 meters long. But let's see what happens when we use TOA for this equation. This time we're going to use the opposite instead of the hypotenuse to work out the length of the adjacent. So our equation reads tan 30 equals 10 over adjacent. And when we put it into the calculator, we find that the adjacent is equal to 17.32 meters. The same result as we got when we used our cos equation to work it out. So in this situation, we could use either to work out the length of the adjacent, but often you'll only be given either the opposite or the hypotenuse to work out the adjacent, and that will force you to use either cos or tan in that situation. But let's change some of the lengths and the location of the given angle. We now have one side length of 25 meters, and another of 20, and an unknown angle. But there is something immediately wrong with this picture. Can you see what it is? Now that our angle is in another corner, our opposite and adjacent labels are in the wrong place. So the first thing we need to do is swap them around so that our opposite side is opposite our angle, and the adjacent side is between the given angle and the right angle. So now that we know that we have been given the opposite and the hypotenuse, the next step is determining which equation we'll use. We can see from our diagram that the only equation that allows us to use both the opposite and hypotenuse is the sine equation. So we can work out the angle using sine theta equals 20 over 25, so that theta equals the inverse sine of 20 over 25, which gives us a final answer of 53 degrees. I hope you've seen in this video that the equations are fairly simple. You just have to make sure everything's labelled correctly and you use the right equation. I have created 4 example questions, so if you'd like to practice your SOH CAH TOA, you can try them out. Put your answers in the comments below and I'll help you out if you have any problems.